only work that is due Sunday night is 6-1 and 6-2 from the pack. Nope, back that up. 6-1 and 6-3 from the packet, and 6-1 worksheet. Basically the things from earlier this week / last trimester. The homework for this will not be due Sunday night, but you should have attempted it. Because then that way I can answer questions on it Monday in class, and then move on after questions. So it's not necessarily going to be due Sunday night, but we'll call it a soft due date, where you want to be able to try the homework to see if you can do it or not. Okay, here we go. So it says, in each of the following problems, translate into a Riemann sum. And then the bottom half is going to be the opposite. Translate into an integral, a definite integral. Now, these are the questions I most frequently see on the AP test, because they are something that is easy to put in a multiple choice question. And so that's where I generally see them, because otherwise this question as a free response might be difficult for them to grade, or my guess is. Oh, Grady, you were enrolled, weren't you? Yes. Okay. Grady? It's your choice. Pick someone else. Go for it.
Congratulations.
Spencer? Okay, Spencer? To do a Riemann sum, we traditionally kind of go in this order, so that if you try to do everything at once, your head just feels overloaded. So first thing we're gonna do is figure out delta x, which is what I was hoping you could help me with. Oh, actually, does it say how many? Oh, so we're gonna be doing an infinite Riemann sum.
Oh, yeah.
So, and the number of rectangles will just be an n.
Okay. So would it just be 4 minus 2 over?
I was gonna say, the only thing you have to figure out is a and b. And on an integral, that's very clear, right?
Yeah.
So it's gonna be 4 minus 2 over n, which is 2 over n. Okay, good. You wanna keep going? You want somebody else to go?
I can probably keep going.
All right, so after figuring out delta x, then we move up a little bit into figuring out what to put in place for an x value in functions, which is x sub k.
So would A be, just 2?
Correct, it's just the same 2 from delta x.
Plus 2 over n times.
Okay.
Times
K, no, you're not putting anything in place of k. Now what you're generally gonna see is they won't write it like this. They are going to usually write it as 2k over n. Especially on multiple choice, they always simplify and do things like that, so sometimes that can be annoying. They might even possibly common denominator these two things together. It's just up to whoever's writing the question and answers. So 2 plus 2k over n. Okay. Maybe we should move up to the area formula. And I'll let you pick somebody else for that. Do I have the area one written up there? Yeah, I do. Okay, who's gonna answer that?
Maggie.
I can give some assistance if you want. I thought I was just gonna let you.
Okay, so you're gonna take the x of k and
Perfect.
plug that into the function.
Okay. Which is?
3x squared minus 1.
Perfect. That's the only other thing we need from the integral over there. Okay, so the function 3x squared minus 1, I'll just put this all in a bracket to try to organize it. So how would I write that? I don't know if it's super easy to you or not. I'll have you tell me what to write for the function with that info.
So it's gonna be 3 parentheses
Perfect.
2 plus 2kn parentheses
perfect. As soon as you said the three parentheses, I knew you knew that. And then is that it?
Then you have to
Oh.
multiply by the delta x.
Perfect, that's super easy to forget. You will find that it's very easy to forget that. So times the width of 2 over n. Now for us, we are not gonna simplify this, we're just gonna leave it like that. You could simplify it, not going to. Okay, last person will be to how to write it as a definite integral. As a summation. Who's that last person gonna be?
Mila.
That was kind of an aggressive pick there. I was worried, did you do something to her, like?
No?
Okay. Now, do you want some assistance starting okay. So the first thing we're gonna do is, because this is an infinite summation, is we're going to write the limit as the number of rectangles goes to infinity. And for, just mathematically, that's basically how you're always supposed to do something where you use an infinity. Theoretically, there isn't anything wrong with just writing sum from 1 to infinity, but this is what they do. So at this point, then we would do the summation symbol.
And then you put it on the other side.
What letter would I put on the bottom?
Okay.
Okay,
Okay.
is this,
Well, let you choose. I'll help you out if you want. I just thought I'd give you a chance. You can look on the previous page if that helps too. I mean, we have a whole packet of notes. That's what they're for.
Yeah,
So we could write n equals 1 to infinity, but we're not gonna put an infinity. Or we could write k, did I say n? We could write k equals 1 to infinity, or k equals 0 to infinity minus 1. Both are correct.
one.
Yeah, almost everybody chooses 1 to infinity, but we're not gonna write infinity because we're not allowed to, so then we write n. That was the whole reason for the writing the limit in the front, is n is going to become infinity. Okay, and then what do I put next to the summation?
The area.
Perfect, this entire expression. And you can write it as exact like that if you want. Yeah. Oh yeah, you could put the 2 over n in front, for sure. Whatever order, it's just the two things multiplied. Now, here's what I would recommend, maybe. Did you guys have a hard time fitting all this information in the box? Oh, wasn't that bad? Okay. I was gonna say, what I would almost recommend is us just kind of writing this stuff as we go. So like 2 over n, once we figure it out, well, this answer is part of the next thing. And then this x value is part of the next thing. So the way you set it up is you could possibly just kind of keep writing your answers, but expanding them as you go. That way it'll save a lot of space, and or write it in one step if you want. You don't have to. If it works easier for you to do it like this, where you just do it step by step, do that. On the next one though, I'll try to show you what I was thinking. So we start off with delta x, which is going to be 0 minus -2, 2 over n. So that's delta x. The x value is going to be a plus delta xk. So we've got -2 plus delta xk. So that's going to be the x value. Then I'm going to take that x value and put it into this function.
Why is delta x positive and not negative?
What?
It's a -2 and 0, right?
0 minus negative.
Oh, you're trying to find, So the reason we subtract them on the top is to find out how far apart the two numbers are.
Oh, okay.
Because it stands for how far is it, hey, how far is it from beginning to end? And so it will always be positive. So that's the x value. We're going to put it into x plus 3 squared. So the x value is what I just wrote. So x plus 3 squared, which obviously could be simplified, but my goal right now is not to simplify, it's just to write it as a summation. So I now just wrote f of x sub k times delta x. So this is the area of the rectangle. And then I'm going to write the summation things in front of it. So this is kind of two different methods for doing the same thing. The first method is to do it in steps and to organize all your information, etc. The second method is still doing it in steps, but the way you organize the information means you don't have to write as much. So some people will probably gravitate towards one or the other.
Wait, what does the value mean?
Which value?
Like it says value just on the table.
Oh, they want you to find the answer for the integration.
Should there be parentheses between, around the -2 and 2k over n?
We could, wouldn't be wrong.
So, but is that right too?
Yep, so the only reason we don't need parentheses is because nothing is being done to the x except for adding 3.
Okay.
So it's certainly not wrong if you put in more parentheses, like to be safe. I mean, honestly, I would actually be combining the -2 and 3.
Okay.
Oh, is that what you're gonna?
Yeah.
Yeah. So the multiple choice answer for sure would definitely have those two combined. Why don't you guys see if you can do the bottom one? And honestly, the trig should have nothing to do in terms of difficulty for the problem. You're not evaluating anything. After we're done translating these, I'll show you how to find the value. What the heck?
Just got caught in the back.
Elena, you got this. And I'm just giving you, telling you ahead of time, so that you can check with people around you, check, whatever. Or I'll get you the marker. I probably made it harder by bringing you the marker first. Did you have any questions on any of it? Are you feeling okay about it?
No, I think I'm good.
Okay, good. Very good, but FYI, don't ever write fractions like that.
Okay.
AP will not like that. While she's writing, I feel like I've mentioned it this year, but maybe I haven't. Don't write your fractions with the angle one. AP does not like those in terms of grading because it's very difficult to tell what is the bottom of the fraction or what is following it. So they prefer very much fraction with a top and a bottom specifically so that you can tell what's the bottom. I also get it's kind of annoying to write fractions in your note in your paper sometimes. Mhm. Oh, your E looks much better than mine. Perfect. No, is everybody else good with this answer or have questions about it? But yes, that 100% that's correct. So my guess is you'll find it easier to go from an integral to summation notation, mainly because the integral is so much more straightforward with what information you're using. Like the 0 and pi is clear, the sine of x is clear. When we get to the bottom half here, some students have a difficult time being able to see past details. I'm not sure the best way to phrase that. So our goal is to figure out three things: A, B, and the function. And it's kind of all jumbled up in this. Now, the function, theoretically, is the easiest part. To me, I can kind of spot right away that the function is going to be 5x minus 1. This entire thing that I circled is going to be x sub k, right? Like we have to put a whole bunch of things in place of x. So it pretty much almost always has to be in the parentheses. And so to me, it sticks out to me that it's 5x minus 1. And then I know we haven't talked about this yet, but you write dx at the end. Okay, now A and B is what we have to figure out next. For some people, this makes 0 sense. For others, it's okay. A is the easiest one of the two numbers to find. Can anybody think how come A is very easy to find?
It's -2.
Okay, so you have to write A directly into x sub k. And so A will generally be just there. I'm not going to call it obvious just because, well, it's written as part of it. So A will always be written as part of x sub k. And then now we have to figure out B. B is not written directly into anything, but we know B is part of 5 over n. We know that 5 is B minus A. That tells me that A and B are 5 numbers apart. So I could do this a variety of ways. Most people find it easiest to add 5 onto A. So -2 plus 5 would give us 3. Whatever the number on the top of delta x is, tells you how far apart A and B are. And A will always be shown directly there, and so then you can add on B to figure it out. These aren't necessarily difficult. Me personally, I find it easier to go from here to an integral, but I'm kind of weird sometimes. Like, I don't know why, but for me, it's just more obvious. This clearly has like way more junk written in it. I just find it easier to do it. And so I'm sure for most people, this is not easier, this is harder. Are you feeling good enough about these that you think you could just try the next one on your own? Try to figure out B. I think C is on the next page, but that's not a big deal. Elena, who's gonna do this problem of the work for us? Way to go, way outside your comfort zone there. Just pick the person next to you. That's right, yesterday I was making people introduce themselves, wasn't I?
You don't need to do that again.
I forgot to do that. I thought that was the greatest thing ever. I mean, me as a teacher, I need some enjoyment from my job at times. That is great.
You have none?
Oh, no, I have a lot.
Okay.
However, just making students feel awkward at times, it's just kind of fun sometimes. Like,
Fair enough.
oh, we're already done.
Yep.
3x plus 4, good, that's perfect. And then it starts at -2, that's good. It starts at -2, that's good. And then you add 2 onto it to get 0, perfect. Done.
Nice.
Okay, now we'll do the last part, which is the column on the right that says value. I kind of put it off because, well, it's not like it's difficult. There's really not much to it. So let's open up the graphing calculators. I don't know. It doesn't matter which one we do, I guess. That's not the graphing calculator. Although I bet you guys would love to do transformations again. Yeah, super easy. Yeah.
Yeah.
I think we should have an entire test on factoring.
You think I should give you an Algebra 1 test one day?
Yes.
Sure. Honestly, I'd be kind of curious how well you do it. It's been so long since you did it.
Just give us algebra lessons instead of
Okay.
off the entire rest of the year.
There's 2 ways to calculate definite integrals. One way is from the home screen. Another way is from the y equals or the graph screen. If you have a TI-83, the graph screen is much easier. I'll show you both ways. But for a TI-84, the home screen is generally quicker. So 2 places to find it. One is under the math button. The other is F2, so alpha window. Number 9, FN int. So it's numerical integration. You can either type number 9 or you can scroll down. Otherwise, it should be very straightforward at here. For the TI-83, I believe you do the equation first, and then comma first number, comma second number? Oh, no. I think it's equation, comma x, comma first number, comma second number. See if that works. You guys don't understand how big of an upgrade it was for them to change it so that you could just type it in as it was. Teaching how to use the calculators before, oh, I don't have a problem to go from, what was the bottom one, -2 to 0?
Yep.
Teaching this on the old calculators took so much longer because there were so many more steps.
3x plus 4.
Perfect, that part I did not remember. And then at the end, you're gonna put dx. The end portion is just telling you which variable is the focus. Enter. Very easy. Your calculator can only give you number answers. And so definite integrals that have numbers here will have a number answer because like as we draw them, it's area under a curve. Okay, I'm gonna do this same problem from the y equals and graph menu. Like this is all there is to it from the home screen, like it's that straightforward. But if we want to graph it, oh boy. 3x plus 4? I think that was the one we did?
Yep.
Okay. We don't have to do the 0 or 2 or anything yet. I don't know where my graph is at. No, yeah, that's not right. Okay, so if you want to find the area under the curve, your calculator can do that for you as well. So once you have a graph on here, you're gonna go to the calculation menu above trace. Like, I call it the calculation menu, I mean, I know it's calc, because that's how you calculate anything from a graph or y equals. And then there should be fn int, or, and I think, I can't remember on the 83 how it's written, but the integration is number 7. I want to integrate from -2 to 0, and so down here it says lower limit. That means the first number, so -2, enter, and then it will say upper limit, 0, and when I hit enter, it will draw it for you as well, just like we have been doing in our packets. And you should get the exact same answer of 2. So there's 2 ways to do it on the graphing calculators. 85 probably has both of them. Is it the same spot? I know it has it on the graph menu.
It's not very user-friendly, so I.
No. Why wouldn't you get a different one by now then?
I've asked.
Okay. I mean, that one was literally the one when I was in high school. Yes, yeah. Sadly, they haven't updated the calculator since then. All they did was come up with different functions.
And make it more user-friendly.
Yeah, it's still got the same computer chip, it's still got the same everything. Well, weirdly enough, they still charge more for the calculators, even though they haven't made them different in 35 years. No,
So it's a nice discrete.
Texas Instruments has a monopoly.
Absolutely.
They do it on purpose. They send all the teachers the stuff for free, where other companies make you buy it. So if it's free for us and cheaper for us, we'll have you guys do it. They're not dumb. Okay, that's it. That's it for the section for right now. I wanted you guys to practice the homework here for the last little bit, so that way you could make sure to know if you're running into trouble. Oh, I can check off homework for sure.